G'day everyone, welcome back to the shed. My name's Mark. Tonight we're going to do some work on the lathe. We've got to make a shaft for an Aveling Porter steamroller, and this will be the scraper bar arm shaft, and we'll have a close look at the drawing in a second. I've already started one and done a lot of the machining. I just have to do some finishing off. But over here to my left on the bench is a sample of an original one and the shaft that we're going to make or finish making. I started doing some of this at my work, mainly because the material I'm using is 57mm diameter 4140. That's what was available, no cost, and so a fair bit of machining has to be done, especially when we step it down to the minor diameter. So from here we'll go and have a look at what's on the computer screen and show you the finished product or the drawing of the finished. Here we have on screen the drawing for the scraper arm right hand side. Gives us all the dimensions. This drawing was done on the 23rd of the 12th 1920. It shows a large radius in the corner there. The sample we have doesn't have that, and ours will be welded on to the bit of plate. So we have to, I've already turned down this 2-inch diameter from 57mm, so 2-inch in metric is 50.8, and then we're going down to 1 3/8, so that's the major amount of material that's got to come off that end. Everything's in imperial measurements obviously, but you can easily convert that into metric depending on what system you work in or whatever you're comfortable working in. The only other thing it has is a half-inch tapped thread in the end. That'll be half-inch Whitworth. That'll be an easy done. The lathe I'm using is a Steelmaster SM1440A. This has been a really good lathe for me over the years. It's coming on close to 10 years or something that we've had this lathe. It does have its shortcomings. It has a few little things that I'm not quite happy with, but I work around, mainly, you know, the size of material into the bore. It's only 38mm. I tried to do some parting, but I started to get a lot of chatter, as you can see, but that's due to the way these lathes are made, the ways, tailstock's probably a bit light. There is a fix. There's a few people, if you look on YouTube, they've done some modifications to their lathes of similar design. This is a Chinese lathe. But all in all, for what I do here at home, it's a damn good lathe. It's got me out of trouble on a lot of things. I've done screw cutting on it, you know, turning, boring, all that sort of stuff that you normally do. So in saying that, let's get on with the project. Because we've got so much to take off, my saw is broken. I've got to get another blade. I'm going to put the fixed steady on the lathe. That'll give me some support, seeing we're so far out, and I'll just machine this off. Yes, it's slow, but that's the best workaround I can do at this moment. For those of you not familiar with a fixed steady, there's also a device called the travelling steady. This is the fixed one that goes into the bedways here. These are all fully adjustable, and as previously mentioned, they support the work, especially when it's sticking out as far as it is. You can, it's too small, grabbing the right Allen key. There we go. When something is this far out, you can machine it, but the problem is you're going to get a lot of deflection, especially if you're taking a heavy cut, and it's not advisable because it just, you know, you're just going to, it's not going to be a good day for you, that's for sure. However, if you've got no other choice and you need to face the end so you can put a centre in it and put the tailstock in, get it machined or get it machining, then that's your only option. With the fixed steady now secured in place, I can go ahead and adjust the fingers here, you want to call them fingers, to touch the steel. And I'll just lock those up where it is, so nothing moves. This does put a little bit of extra drag on the surface of the machine. You can, especially in the smaller machines like this, you can hear it working a little bit harder. And of course, lubrication is very important. And we'll just put a bit of oil on there. Once we get going, it'll start to lubricate itself. We'll get a thin film of oil going. So we'll just give that a bit of a slow run. And we'll bring the speed up to 300. Right, that's running nicely. We'll reposition the camera and we'll have a crack at facing this off. Okay, a lot of editing to do there, but anyway, let's see how this goes. As you can see, the fixed steady supports the work, and I was able to take a nice cut off there. It's only a very small cut, but we'll get a bit deeper and we'll just repeat the process over and over until I get down to the finished length. Up the speed so we can get the job done a little bit quicker. We are getting a little bit of vibration, but everything's looking all right, and we'll put a bit more oil on. We're at 460 RPM, everything's working great. The swarf that's coming off, this is swarf or chips, fairly long. I'm going to increase the depth of cut, so I'll be working the tip a bit harder, hopefully, and that'll change the performance a bit to hopefully get it to chip a lot better. So I'll be taking 2 millimeter depth of cut. We'll see what happens. You can hear we get a bit of vibration as we get towards the end of a cut, especially when we stop feeding or slow the feed rate down to get towards the end. it's not ideal, but it's getting the job done. Right, well, seeing you this far into the video, hopefully you're still here with me. Give it a like, click subscribe, keep up to date with what's going on. I do a live stream on a Thursday night, try and put out a video at least once a week, maybe a little bit more. And leave a comment down below, tell us what you think, or if you don't like it, thumbs up, thumbs down, whatever, doesn't matter. Let's get back to it. Just as we're getting down to the nitty gritty here, I'll explain a couple of things. Just putting a periodic drop of oil on there to keep everything lubricated, and also the coolant. Now the coolant does a couple of things. It's a soluble oil, comes in different sort of shapes and sizes in terms of colours and things like this. So it's a sort of a creamy coloured, off creamy coloured look, the stuff I'm using. It lubricates, it helps, and in the name, coolant, it helps cool your workpiece, even though that's pretty hot, we're working it pretty hard. It also puts that little layer of lubrication on there and helps prolong the life of the tool tip. So it does a couple of little things, and it's quite important, especially if you're in a manufacturing situation where you're doing a lot of repetition work, doing a lot of this sort of stuff. You'll see machines, the tooling is flooded with coolant. So with that, as we're getting down in size, I'm going to back off. We're taking 2mm cuts. I'm going to back off and go to 1mm cuts and just machine it down to nothing. At this point, I'm going to grab the hacksaw and chop that little bit off. Get rid of some swarf. Let's see how we go with the hacksaw. I've got some long bits, swarf hanging around here. That's better. I think the old hacksaw blade's getting a bit thin. In fact, I'll change my mind again. I'll go over to a different tool. One I was using the other night. It's right there. It's got a much sharper point on it. I'll turn the tool post around, and that way I can get into the corner and just machine it down to very little. Let's get that out of the way. So I've been able to machine it down to a very fine point, as you can see, or maybe you can't, and then we just break that off. So while we've got our tool in here, I'll just angle that over a little bit more. I'll get the ruler out and I'll measure that. And then we'll just take a couple of facing cuts to get it down to length. 235mm or 9¼ inches. So let's do another measure of that. I'll use the auto feed. That's just going to save me winding it in and get a bit. Righto, let's get a check measurement. Oh, that's spot on. We'll just chamfer the end. In fact, we'll change tool because this will be welded on to a plate, so we need a bit of weld prep. And there we have it, down the size, chamfered. This end's finished, so we'll just take him out, spin him around and do the 1/2 inch hole in the back, in the front, sorry. And that'll be this one done. We're going to leave this on here because I'll be using it again. I'll have to push the little fingers in a lot further. Carrier supports, fingers, whatever you want to call them. Being a Friday night, it's been a little bit busy around home with the usual Friday night hoons and motorbikes going crazy and doing their thing. In fact, I've already got a centre in here. There we go. A fixed steady it's come in handy so I can rest it on there. Here comes Evel Knievel now. Don't know whether you can hear him or not. I probably should turn the background noise cancellation off so you guys can hear that, because he certainly gave it to it when he got around the corner there. Now, I'm not putting a lot of pressure on these. It's just there to support it. Not going crazy. I'm not doing any great big holes. And the last operation worked pretty well. Drill's a little on the blunt side too, so I'll run a pilot drill down there. That'll make a world of difference. Right, that pilot drill has made the world of difference. We're almost there. Righto, let's turn that off. Righto, so I've got me 1/2 inch Whitworth starting tap. I don't know how far I can get with this. Slow the lathes right down. Get and bust out the old Trefolex, the thread cutting compound. Stuff is old as the hills. I'll give it a bit of a mix up. Now, those of you who've used this stuff, we can also see it here, Trefolex. It's basically a grease type thing. I haven't used this in ages. So we'll lather that on nicely, see how far we're going to get. And then we'll switch over to a finishing tap or a bottoming tap. Right. Yep. As I thought, I didn't get too far with the tap in the chuck. It's just slipping. That's all right. I'll be able to got it started. Tap wrench is probably a little bit bigger than what we need, but it'll get the job done. It's going in nicely. We'll just back it off a little bit just to break the chips. Even in low range, so I'll just put my foot on the brake. Right, here's our finishing tap. This has got a nitrite coating on it. The gold coating is to make it last longer. Once again, we've got our lubrication on there. It's cutting very nicely. I've used this tap quite a few times. It's probably getting a little bit blunt. And with this sort of setup, what's happening is as we're cutting and backing off, the chips are breaking off and they're getting further pushed into the hole. Normally I'd blow this out with compressed air, but oh yeah. I was going to say I didn't think I had any air in the compressor, but I do, so I'll do that. Righto folks, the job's done. We do have another one to do, as I mentioned before. I'm not going to show that because it's just an absolute repeat of what I've already done. Righto, that's a wrap on this job tonight. As I mentioned before, we do have another one to do. I'm not going to show that, it's only a repeat of what I've already done. I'd just like to thank you for watching and stay tuned. If you haven't, subscribe already, keep up to date with what's going on in the shed. Thursday nights live, 8 PM Australian time, Australian Eastern Daylight Time. And I'll give you a rundown on what we've been doing on the steamroller or whatever's been happening in the shed here. Give us a like, throw us a comment down below. Appreciate your support if you've been watching this long. See you in the next one. Bye for now.